This is Data Mining Concepts Part 1 by Emmanuel Iacob and Jake Alton. Data mining. The definition of data mining is that it is a non-trivial process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data. Why is it important? Data mining is important because of the recent upturn of the amount of data that goes into database management systems, DBMS, and the ability to use that data to find patterns, trends, classifications, and/or clusters in seemingly unrelated data for use in business, computer science, and engineering. Now, some of the data mining in businesses today, the 5 most used data mining paradigms are considered classification, clustering, statistical learning, association analysis, and link mining.
All right, and I'll go into the 5 different types of data mining in business today. So we start off with classification, and in classification, basically, it's used often in machine learning algorithms, and it's basically used on a given collection of training data to obtain an appropriate abstraction of the data set. Most often, or at least very recently, it's been used in support vector machine algorithms. And an example of that is just a classification that's often used in linearly independent binary data sets because of its robustness and its indifference to dimensions. Second is clustering. Clustering is basically just a simple method of partitioning given data sets into groups based on some common attribute. One way we've seen clustering is through k-means, and it's basically a clustering algorithm that groups data sets into user-specified number of clusters, which are k-values. And the way it does it is each data point is assigned to its closest centroid that we've defined as k, with ties broken arbitrarily. And in the second step, what it does is each cluster then representative is relocated to the center of all data points assigned to it. So after you've assigned its closest centroid, the centroid itself moves to the center of all those points that are assigned to it. The algorithm ends up converging when the assignments are no longer changed. So as we start to get closer and closer to the center. Statistical learning is also something we've been doing in class. Basically, it deals with the problem of finding a predictive function based on the data. Supervised learning is a large part of statistical learning. Some examples of supervised statistical learning involves learning from a training set of data and inferring the function that maps between the input and the output. Therefore, being able to use that learned function to predict output from future input. Basically, things like linear regression, logistic regression is a big way or a big part of statistical learning. Association analysis. Basically, association analysis discovers interesting relationships hidden in large data sets to help predict outputs. Business enterprises accumulate large quantities of data from their day-to-day operations, and an association analysis would be used to predict customer trends in the future. For example, Kroger does a click list, which is basically you can order your groceries online and pick them up at the store. So if Kroger were to see that you ordered eggs, chicken breast, breadcrumbs, a jar of spaghetti sauce, and Parmesan cheese, by association analysis, Kroger might suggest that you would need a recipe for chicken Parmesan. Link mining is the last one. Link mining is a technique of data mining that explicitly considers links between data when building predictive or descriptive models of the linked data. This is a exclusively supervised style of learning, as opposed to the one before where it was unsupervised. So link mining can be broken into 2 categories, homogeneous networks and heterogeneous networks. Homogeneous, the basic idea is that there's a single object type and link type. Examples of this are single mode social networks or the World Wide Web. And the heterogeneous networks, there are multiple objects and link types. So basically you look at medical domain describing patients, diseases, treatments, and contacts. So what does data mining look like in MATLAB? We've got 3 examples here. The first one is statistical learning, and the one that we learned in class was the Gaussian regression. The mathematical model is right there. And in the MATLAB formula, you can see the main part about the statistical learning part is you'll see you actually load in training data, which is x2x.dat and x2y.dat. And inside the loop, you've got the for loops from k to 2 to 500,000. You're basically running through that mathematical model. It will end up giving you a WB1 and WB2, and that is going to be used for your predictive model for future input. The next one is going to be k-means clustering, and in k-means clustering, what it does, again, it's a very simple algorithm, the way it's written actually even in MATLAB. MATLAB has its own function of how it writes k-means clustering. So in this one, we're generating random number generators. We use 100 random numbers, and we put it into 2 different clusters, and we look at the Euclidean distance between them using 5 replications. So then once we do that, we can figure out the center and of the centroids of the 2 clusters. Okay, last one is classification, and what we look at in here is the neural network classification. The mathematical model is down there for the autoencoder. So basically what the this classification does is look at a wine data set, and it uses training data. So we can see a hidden size of 10, which basically says it hides 10 points of the data in the first run, and it tries to predict, and then it runs through the encoder one more time to learn again, to teach the algorithm, and then it'll learn one more time, again hiding 10 points, and it runs through one more time. Then it's able to use the features of the wine data set to run through this autoencoder to be able to predict what type of wine it is and plot a confusion plot based on that. So that is part 1 of data mining.